The license isn't counting your cores. Oracle uses a processor core factor table by chip family, so many x86 servers are billed at a reduced processor count before separately licensed options and support are added. It sounds like core counting, but Oracle is really core reclassifying. How does Oracle turn ordinary server hardware into a licensing multiplier? And where does the real lock-in begin? This is No Tech. When a platform engineer slides a standard 2U rack-mount server into a cabinet, they assume a direct relationship between the silicon they bought and the software they run. If you buy a server with a certain number of physical CPU cores, you expect the software license to simply count those cores. You provision the hardware, deploy the database, and the procurement cycle closes. And if you look at the public pricing documents, that assumption seems perfectly logical. Open the public Oracle price list, and you'll find Oracle Database Enterprise Edition publicly listed at $47,500 per processor license. The industry shorthand, the common belief that gets passed around in architecture meetings, is that Oracle processor licensing is just a one-to-one count of physical CPU cores. Many teams also assume that buying Oracle Database Enterprise Edition automatically includes major add-on capabilities like clustering and advanced diagnostics. The initial capacity math feels straightforward. You count the hardware, buy the software, and run the workloads. But when you actually rack the hardware, the final invoice rarely matches that simple estimate, which forces a specific mechanical question about the architecture. Why does a 64-core AMD x86 server often show up as 32 Oracle processors before any options or support are counted? Hold that number. We'll come back to it when the table meets the rack. Now, move from that pricing page to the physical data center floor. This is where the hardware actually gets cabled, provisioned, and powered on. Install a modern dual-socket server with two 32-core processors, and you have 64 physical cores of compute power. To the operating system, that is 64 distinct execution units. When a systems engineer looks at a modern AMD EPYC processor, they see massive thread counts designed to handle thousands of concurrent queries. But Oracle's processor metric is not a raw core count. The licensing auditor doesn't look at the threads. They look at the socket, the physical cores, and the specific architecture column in the core factor table. This table is the hidden multiplier that converts silicon into billable processors. For many modern Intel and AMD x86 server CPUs, Oracle's core factor is 0.5. This creates a recurring motif in enterprise architecture, the half-core. Because of this specific chip family weighting, that 64-core server would typically count as 32 Oracle processors. At first, this looks like a massive vendor concession. To a procurement team, the 0.5 multiplier feels like a discount. They see a 64-core AMD x86 server and budget for 32 licenses. But this is where the architecture traps the budget. The core factor table doesn't exist to give you a discount. It establishes a baseline metric, the Oracle processor, that every other piece of software attaches to. Because license costs dwarf silicon costs, infrastructure teams often buy specialized, high-frequency processors with fewer cores just to minimize the software bill. The hardware is chosen to fit the contract. The math is no longer one server, one core, one license. The chip family factor and separate options turn the bill into a staircase. The core factor table is only the first step in the calculation. The base license establishes the footprint, but not the final cost. To understand why, you have to look at what happens when the database actually performs in production. Open the procurement dashboard and look at the actual receipt line. This is where the assumption about what you actually bought falls apart. Enterprise Edition is only the base, not the bundle. Several Oracle database options are licensed separately from the base Enterprise Edition. To run your database across multiple servers for high availability, You cannot just turn that feature on in the configuration file. You need real application clusters, or RAC. Oracle has publicly listed real application clusters at $23,000 per processor. If your tables get too large and you need to manage them in smaller chunks to maintain query speed, you need partitioning. That is publicly listed at $11,500 per processor. To use built-in performance monitoring tools to figure out why a query is slow, you need the diagnostics pack, listed at $7,500 per processor. And if you want the system to recommend index changes to fix it, you need the tuning pack at $5,000 per processor. Each of these options is calculated using that same 32 processor count we established earlier. The options stack is where the real margin lives. A database without performance monitoring is flying blind, and without high availability, it's a single point of failure. Enterprise teams are effectively forced to buy the options. When a critical query locks up at 3 in the morning, an operator cannot wait for a procurement cycle to approve the diagnostics pack. They need to see the active session history immediately, so the feature gets used. When engineers enable a feature in the command line, they often unknowingly trigger a new line item on the invoice. The database engine doesn't stop you from turning on partitioning. It simply logs usage in a background table, and the compliance audit catches it later. The receipt line keeps growing because the architecture requires the options, and the options require the licenses. The same pattern shows up in why Snowflake's pricing costs way more than advertised, where the sticker price turns out to be only the beginning. And we haven't even reached the support phase yet. Oracle software update license and support typically starts at 22% of net license fees. That 22% applies to the base database license and to every separately licensed option in the stack. Every single year, and it is subject to an annual inflationary support price increase. The initial $47,500 per processor license was just the entry fee. But what happens when you try to limit where those licenses apply? Now, move from the procurement dashboard to the hypervisor console. In a modern data center, very few workloads run directly on bare metal. They run inside virtual machines. This introduces the boundary line. If you have a cluster of 10 physical servers, but you only run Oracle on 2 of them, you naturally want to pay for just those 2 servers. You use virtualization software, like VMware, to pin the database to specific hardware, isolating the Oracle workloads from the rest of your corporate applications. But drawing a boundary line in software does not mean the vendor accepts that boundary in an audit. Oracle has a specific stance on what it calls soft partitioning. The research bundle says Oracle's soft partitioning position is influential in audits, often leading to claims that the entire physical cluster must be licensed. If a virtual machine can theoretically migrate to any server in the cluster, the argument goes, then every server in the cluster requires a license. When compliance teams run measurement scripts, they aren't just looking at where the database is currently running. They query hypervisor logs to see everywhere the workload could have migrated across the shared storage fabric. However, it also notes that enforceability is disputed here because the bundle does not include the specific partitioning policy document or a signed contractual clause. The boundary line becomes a point of intense negotiation. Engineers look at the hypervisor configuration and see a contained workload. Auditors look at the shared storage and migration capabilities and see a cluster-wide deployment. If the boundary line fails, that 32 processor calculation doesn't just apply to one server, it applies to every server in the cluster. A single VMware cluster could suddenly require hundreds of Oracle processor licenses, plus rack, plus partitioning, plus the 22% support charge. This multiplier risk forces companies into defensive architecture. They build dedicated, physically isolated server clusters just for Oracle, stranding compute capacity to avoid licensing exposure. So, teams look for an escape hatch. They look to the cloud. If the physical hardware rules are this complex, surely moving to a managed cloud environment simplifies the math. But you cannot project on-premises core factor logic onto cloud environments. Oracle's cloud licensing documents for certain approved vendors state that the processor core factor table is not applicable. The rules change completely depending on whose data center the software is running in. In an authorized cloud like AWS or Azure, the standard policy counts 2 virtual CPUs as one Oracle processor license if hyperthreading is enabled, stripping away the 0.5 hardware advantage you relied on in your own data center. The math resets and the baseline shifts. A workload heavily optimized for the core factor table on premises might suddenly double in licensing cost when shifted to the cloud, simply because the contractual definition of a processor changed overnight. Which brings us back to the anomaly we found on the data center floor. Remember that annotated Oracle technology price list from the opening? Why does a 64-core AMD x86 server often show up as 32 Oracle processors before any options or support are counted? Because the hardware is just the raw material. The contract is the actual machine. The journey from the rack to the invoice reveals the true architecture of lock-in. Enterprise Edition is only the base, not the bundle. Intel Xeon Scalable and AMD EPYC-style x86 server CPUs often sit at 0.5 in the core factor table. That reduces the initial count. But then, support and separately licensed options stack after the first billable count. Once the core factor, options stack, and support are visible, the lock-in isn't the server, it's the table. The vendor controls the multiplier. They control the boundary line, and they control the receipt line. Oracle sells hardware math, not just database software. By the close, the price list is no longer a catalog. It is the mechanism. Oracle's processor core factor table can turn an AMD x86 server into a reduced processor count, then separate licenses for rack, partitioning, diagnostics pack, and tuning pack stack on top. If processor licensing can be reshaped by chip family instead of raw silicon count, what other infrastructure costs are hiding in plain sight inside the contract rather than the server? We follow the paperwork, price lists, and hardware tables first, because in enterprise infrastructure, the bill is usually encoded long before the invoice arrives. Compare your Oracle server against the processor core factor table and tell us whether the 0.5 factor or the separately licensed options changed your estimate most. See you on the next License Trace.